Hey guys, welcome to my channel. Welcome back again. Today we are going to solve the 15th question of the review exercise from unit 6. Now you have to balance the chemical equation. First is, let's see what do we have here. First part is Na plus H2O will give NaOH and H2. Balanced equation is by two ways. You can just multiply the equation with 2 because here we have one sodium atom and here we have one sodium atom, but hydrogen is 2 here, oxygen is 1, and here we have one oxygen and 1 plus 2 hydrogen. So to balance the hydrogen you have two ways. You just multiply all the values with 2, or you can simply multiply H2 of the product here by 1 by 2. It will result in the cancellation of 2 in the denominator with 2 in the subscript, and the whole equation will be balanced. Next is NH3 gives N2 plus H2. Now it is very simple. Nitrogen here is 1. Here we have 2 nitrogen atoms, so we will multiply this with 2. Hydrogen here is 3 and here is 2. Now by multiplying with 2 it will become 2 into 3 6. We simply multiply this hydrogen with 2 to get the final answer. And now the equation is balanced. Now let's see for the next question. Next we have question number 16. Potassium is in group 1 element and we have to find out the formula which forms potassium oxide and potassium nitride. So the first part is to predict the formula of potassium oxide and potassium nitride. First is the given data. So the charge of potassium we know is +1 and charge on oxygen is -2. We have to find its formula. So we'll go for the solution. Let's see what it is. Determine the number of potassium ions and balance the charges on both the atoms. So we will write a dash along with the potassium, multiply it with the oxygen, so it will become K dash multiplied by oxygen. So it will result in X because it is unknown which value should be put over here. So we will multiply it with +1 because it is the charge of potassium, +1 because we have one oxygen atom, and multiply it with the charge of oxygen, that is -2, and let's get it equal to 0. After solving this it will become 1x, and plus into -2 it will result in -2 equals to 0, and if you move -2 to the other side of the equal it will become x equals to 2. So it means X is with potassium, so we have 2 atoms of potassium in the formula and 1 oxygen. So this formula K dash XO will become K2, which is the value of X, so it will become K2NO, so the formula will be K2O. Next, number 2, potassium nitride. Now the charge on potassium is +1 and on nitride it is -3. We have to find its formula. Let's see for the solution. Again we use the same technique, K, X and N. K is multiplied by N, where dash is representing the X number of atom, means how many atoms of potassium do we require here. So X will be multiplied by +1 because it is the charge of potassium, plus 1 atom of nitrogen is here, so we will write +1 and multiply it with -3, which is the charge of nitrogen, so it will become -3. So overall, by solving and simplifying the equation, it will become 1x, and plus into minus will result in -3. So overall it will become x equals to 3. So it means the value of x is 3. We can write K3, and N has none of the value, so the result will become K3N. Now the second part of the question is, a 0.5 gram sample of potassium was added in 200 centimeter cube of water. We have to show that 1.28 into 10 to the power 22 into 10 raised to minus 2 moles of potassium were added to water. So the given data is mass of potassium 0.5 gram is given, then the molar mass we know it is equals to the atomic mass, that is 39 gram per mole. We have to find the number of moles of potassium added to water. So solution will become simple. The formula will be used, number of moles equals to mass of potassium into molar mass of potassium. Put the value 0.5 by 39 and we'll get 0.0128 or 1.28 into 10 raised to the power minus 2 moles. So this is the actual result. Now the next part is to balance the chemical equation. Now there are two ways again to balance the chemical equation. To balance number of hydrogen because it is different on both sides of the equation. Either just multiply the whole equation with 2, like this will become 2 potassium atoms here and 2 potassium atom here. 2 into 2 4 hydrogen atoms here, and 2 are this hydrogen atom and 2 this hydrogen. It will become 4 and 2 oxygen here and 2 oxygen here. Or the simplest method is just multiply 1 by 2 with hydrogen on this side. The denominator, it will cancel out the 2 in the subscript, and the whole equation will be balanced, like 1 potassium here, 1 potassium here, 2H2 here, and 1 hydrogen is here and 1 is here, so 1 plus 1 technically becomes 2, 1 oxygen here and 1 oxygen here. Now the fourth question, transform the above chemical equation into ionic equation. So this is very simple. Just write the substances that are soluble in water in its dissociated form. Like potassium is solid, it is written as it is. H2 is liquid, as it is. KOH was aqueous, so K plus is written separately and OH is written separately plus H2. Now none of the atoms and molecules on both sides of the equation are same, so none is cancelled. So this is the actual equation that is ionic in nature. Now fifth one, calculate the number of atoms present in the sample of potassium. Given data is the number of moles given, 1.28 into 10 to the plus 2 moles. Avogadro's number is a constant value. We have to find the number of atoms. Simple formula will be used, that is number of moles into Avogadro's number. Put it the value and we'll get 7.7 into 10 raised to the power 21 atoms as the final answer. Now the last question, the sixth one, predict the period number of potassium in the periodic table. If we look at the periodic table, we'll know that it's present in the fourth period. So it's simple. That's the final answer. That's it for unit number 6, and I hope you'll understand the whole thing by looking and revising the lectures. Keep revising and keep tuning in, and do subscribe my channel so you'll get the latest updates. Now that's it for unit number 6. Keep watching.